Hello guys, welcome back to another video. Today we'll be looking at energy, which is a topic of physics. So guys, first we'll be looking at keywords relating to this topic. So the keywords that will be included in this PowerPoint is potential energy, conservation of energy, specific heat capacity, power, and work. So all the other keywords will be included in part 2 of energy. So potential energy is just energy stored in the system. The conservation of energy is a rule that states the total amount of energy stays the same. Efficiency is a proportion of energy supplied that is transferred usefully. So Sankey diagram can show the amount of useful energy and wasted energy. Dissipated is when energy is lost, usually as heat. Work is a transfer energy. Power is a rate of doing work energy. 7. The specific heat capacity is the amount of energy required to raise the temperature of 1 kilogram of substance by 1 degree. Energy resource is a way of getting energy for generating electricity. Renewable energy is a resource that can be replaced. Non-renewable is a resource that cannot be replaced. A fuel is a store of energy. Fossil fuel is a fuel made from the remains of living things. So these living things are like dead animals. So how energy is stored. So these are like the 4 main ways energy is stored, but we will be looking at more in the coming slides. So elastic potential energy is energy stored in a stretch spring. It depends on the spring constant, the stiffness of the spring, how much the spring is stretched, the extension. So the formula for this is elastic potential energy is half times spring constant times extension in meters squared. Gravitational potential energy is energy stored in an object because of its height above the ground. Formula is GPE is mass times gravitational field strength times height. So kinetic energy is the energy an object has because it's moving. It depends on the object's speed and mass. So the formula for this is half times mass times speed squared. And finally, power is a rate of doing work energy and is measured in watts. Power is energy divided by time. Work done. When energy is used, it is transferred from one type to another. We say that work is done. The amount of work in joules is equal to the amount of energy transferred in joules. Whenever a force is applied to move an object, e.g. lifting a box, work has to be done. So energy stores. So these are the main energy stores we need to know. So chemical energy, which is in food, fuel, and batteries. Kinetic energy, which is in a moving object. Gravitational potential energy, which is more in an object lifted above its planet. Elastic potential energy is in a stretched spring. Thermal energy is in an object at high temperature. Magnetic forces between poles. Electrostatic energy is in electric forces between charges, so in currents and circuits. Nuclear energy is in the immensely strong forces in atomic nuclei. So specific heat capacity. So what is specific heat capacity? So I'm going to explain this as an example. If you calculate how much energy 1 kilogram of water needs to become 10 degrees hotter, you'll find it needs 4,200 joules. This number is called the specific heat capacity. The explanation is the specific heat capacity of a substance is the amount of energy that is required to raise the temperature of 1 kilogram of a substance by 10 degrees. Copper is used for pans as it has a very low specific heat capacity and hence warms up very fast. On the other hand, water has a high specific heat capacity and hence it takes a lot of energy to heat up the water for a bath. So the formula for this is specific heat capacity times mass times change in temperature. So in an exam, this is given to you in the formula sheet. So we'll be looking at practical today. So the aim of the practical is to measure the specific heat capacity of a sample material. So the method. So place the immersion heater into the central hole at the top of the block. Number 2, place the thermometer in the smaller hole and put a couple of drops of oil in the hole to make sure the thermometer is surrounded by hot material. Fully insulate the block by wrapping it loose with cotton oil. Record the temperature of the block. Connect the heater to the power supply and turn it on after 10 minutes. After 10 minutes, the temperature will still rise even though the heater has been turned on, and then it will begin to cool. So what we need to record is the highest temperature it reaches and calculate the temperature rise during the experiment. So this is a required practical, and it's really important as well. Also, another key term related to practical is that a measurement or calculated value is considered accurate if it's close to a true value. So guys, finally, we'll be looking at the law of the conservation of energy. Also, another name for this is the principle of conservation of energy. So the law of conservation of energy states that the amount of energy always remains the same, and in any process it can only be transferred from the different stores of energy. So like we learned, mechanical, kinetic, elastic, so it can only be transferred. So if we think about light, sound, and electricity, there are ways of transferring energy from one source to another, but they are not stores of energy. In addition, you can't buy a box of electrical energy, if as an example, but you can buy a cellular battery. In a circuit, the chemical energy stored in a cellular battery causes electric charge to flow. Thank you for watching, guys. I hope you enjoyed my video. Please like my video and subscribe to my channel.